Welcome to the lecture series of Basic Electrical Engineering. Subject code is ECE 101. The topic of today's video lecture is single phase transformer. In this video lecture, we will discuss about the basis of transformer, working principle of transformer, transformer construction and its types, core type and shell type. So first of all, the basic definition of the transformer. The transformer is defined as a passive electrical device that transfers electrical energy from one circuit to another through the process of electromagnetic induction. It is most commonly used to increase, that is called step up, or decrease means step down, voltage level between circuits. The transformer is a static or stationary piece of apparatus by means of which electrical power in one circuit is transformed into electric power of same frequency in another circuit. Means that the transformer is a device which transforms electrical energy from one circuit to another without changing the frequency of the circuit. Basically, the transformer is a device for transferring electrical energy from one circuit to another without change in frequency. The transformer accomplishes the change in voltage without use of moving parts, and therein lies its advantage. That is why it is called static device. The cost per kilowatt is comparatively low and the efficiency is high. The cost per kilowatt is comparatively low means that the wattage produced by the transformer is of low and it gives high efficiency, and efficiency is nearly 98 to 99%. As a matter of fact, the transformer is the most efficient piece of electrical machinery, and efficiency of 98 and 99% are not at all uncommon. It gives a very good efficiency. Since there is no moving part, maintenance is simpler and cheaper, and the required insulation for the extremely high voltages obtained can more easily be constructed, because we are not having any moving part in the transformer as in the case of motors and generators. Because of unmoving part, its maintenance is easy and simple. Now we are moving on the working principle of a transformer. Physically, a transformer is mutual inductance between two circuits linked by a common magnetic flux. It consists of two inductive coils which are electrically separated by magnetically linked through a path of low reluctance as shown in figure. The two coils possesses high mutual inductance. This diagram shows the basic principle of the transformer. Here we are having this is called the magnetic core, and on this side, left side, we are having the primary coil. These are the primary windings, and on the right side we are having the secondary windings, and the windings, number of windings on the primary side are denoted by NP. N means the number of windings and P is the windings of primary side, and NS, it is number of windings on secondary side. In some cases we can write it as N1. N1 means primary winding and N2 means the secondary winding. It varies from book to book. And VP is the primary voltage which we are giving. And on the secondary side we are having VS, which is called secondary voltage. So VP is the primary voltage, VS is the secondary voltage, NP is the number of primary windings, NS is the number of secondary windings, and phi is the flux linkage. Phi is this, the flux linking between the primary and secondary. And this is the transformer symbol, which is shown by the coils. These two parallel lines are called magnetic cores, and this is the primary side and this is the secondary side. When we are having the complicated circuit, we represent this by this symbol, two circles, and this is primary and this is secondary. This arrow shows primary to secondary. So if one coil, now I am explaining the working principle of the transformer. If one coil is connecting to a source of AC voltage, an AC flux is set up in the laminated core, most of which is linked with the other coil, in which it produces mutually induced EMF according to Faraday's law of electromagnetic induction. As shown in this diagram, this is the primary side. When we are giving the AC supply to this primary winding, as written here, if a coil is connecting to a source of AC voltage, when we are connecting AC supply, AC flux is set up between the laminated cores, the most of which is linked with the other coil, in which it produces mutually induced EMF. Means that because of the applied voltage, the EMF is induced on the secondary side. If the secondary coil circuit is closed, a current flows in it. Means that if we are having the load across the secondary, the circuit is complete and current flows in it, and so electric energy is transferred from one coil to the second coil. Means from primary coil to the secondary coil. The first coil, in which electrical energy is fed from AC supply, means is called primary winding, as I have told you in the figure, and the other from which energy is drawn out is called secondary winding. In brief, a transformer is a device transfers electrical power from one circuit to another. It does so without change in frequency. It accomplishes this by electromagnetic induction, where the two electric circuits are in mutual inductive influence of each other. So this is the brief introduction of the transformer. Now moving to the construction of the transformer, we are having two main transformers, core type and shell type, based on the construction. In the so-called core type transformer, the winding surrounds a considerable part of the core, as shown in figure. In this figure shows the core type transformer, in which the windings are wrapped on the cores. For the core type of transformer, the primary and secondary windings are located on the opposite legs or limbs of the core. This is called core, and these are the opposite limbs or the legs. So windings are wrapped opposite to each other. These transformers are quite favorite in high voltage practical applications like distribution, power and auto transformers. So further, in the core type transformer, magnetic core is made of L-shaped strip. The core type transformer consists of an iron core surrounded by winding. The core of the transformer has two limbs, as shown in this figure. Each limb carries the same flux, therefore area of both the limbs are equal. The low voltage winding is placed next to the core and high voltage winding is placed over it. Proper insulation is provided in between core, low voltage windings and high voltage winding. So this figure shows the core type laminations. We are having the U shape and I shape or the L shape. So these are the when we connect these, this makes a core type transformer, and these are the opposite limbs on which we are having the windings. This shows the practical diagram of core type transformer. This is a three-phase transformer. Here we are having the three different windings, and this is the single phase transformer. Then in shell type transformer, the core surrounds a considerable portion of winding as shown in figure. Half the primary and half the secondary winding have been placed side by side or concentrically on each limb, not primary on one limb and the secondary on the other limb. Means that as in the core type transformer, we are having the primary and secondary windings on the different limbs, but in the case of shell type transformer, we are having the primary and the secondary windings on the same limb, on the central limb. This upper part shows the primary winding and this lower part shows the secondary winding, and this is the core, and this dotted line shows the flux produced because of primary and secondary. In core of shell type transformer, the core of shell type transformer is made from E and I strip. The shape of the core is E and I. The lamination as shown in figure, this is E and this is I. The lamination of this transformer has three limbs. Three limbs means 1, 2 and 3. The side limbs carry half of the flux, whereas central limb carries the whole of the flux. Therefore, the width of the central limb is more than the outer limbs. These outer limbs are smaller as compared to the central limb because the central limb carries the full flux, as compared the side limbs are having the half flux. Another diagram shows the E shape and the I shape core of the shell type transformer. This is the practical diagram of shell type transformer. This is three-phase diagram and this is the single phase diagram. So this is all about the transformer. In this lecture we discussed about the basis of transformer, in which we discussed the working of the transformer and the different types of the transformer. So this is all about your lecture. Hope you like this lecture. Thank you so much.